Hello everyone, my name is Aditya. In this video, we'll see how to interface an OLED display with an Arduino Nano. So the version which I am using, the OLED display has the provision which can be converted from SPI to I2C. So we'll also see that conversion and then try to run the example sketch on both the version. So first we'll see the OLED display types. On the left you can see I2C, which uses 4 pins, but it is slower compared to SPI. On the right you can see an SPI version which uses 7 pins and it's faster compared to I2C. So there is always a trade-off between the number of pins and the update rate. So if you want to use lesser number of pins and you are okay with the slower update rate, then you can use an I2C. But if you are okay with using more number of pins and you want the update rate or the refresh rate to be faster, you can use an SPI version. So generally the SPI version will have the provision to be converted to I2C. This is the OLED display. So it comes with the pin headers, so we need to solder it on the OLED display. So let's solder the pin headers and come back. So these are the connections that we need to do from Nano to OLED display. On the left you can see the I2C version of the board, and on the right you can see the SPI version. So we'll also try to convert this SPI version to I2C, and then we'll see that connection later in the video. Okay, so once the connections are done, we'll see the programming part. So we need some libraries for it. So go to library manager and type in OLED. You can see a lot of libraries are available. So we'll install Adafruit SSD 1306. Click on install, then it installs the bus IO library and GFX Adafruit library. So click on install all, and you can see that the libraries are installed. So once it's installed, go to file examples, and inside the Adafruit SSD 1306 you can see your example codes. So select your respective board and the communication protocol. For me it is 128x64 and SPI. So after selecting this, you can see the code for the example code. So in this example they have written some pre-defined logos and lines and some shapes and some characters and hello world, and it also has some stars being displayed. Okay, so here is a pin configuration that we have connected. So pin number 9 is D1, then pin number 10 is D0, and DC to 11, CS to 12, reset to 13. Okay, so we'll try to compile and upload this, and let's see whether our display works. So after compile, hit upload button. So once you press the upload button, it will upload the program onto your Arduino Nano, and we'll see the display. Okay, so first Adafruit logo is displayed, then we have some lines, and then the shapes are being displayed one after the other. Okay, so this is the example code. Now we'll try to use this code to write our own text onto the screen. Let's say I want to write my name. So for that we'll make use of some of the lines of code. For the setup we need till here. We'll just copy this. We need some we need to include some h files, then the screen width and height, and the pin configuration. So this is the setup part. So inside the setup we'll write some code. So we need the serial begin, and we need to display this, whether if it is unsuccessful it displays allocation failed. So we need this. Then we need to display whatever is there in the buffer, and then delay it, and then clear the display, draw the pixel at 10,10 and display it and with the delay. So we'll copy this till here, then write it here. So till here it displays the logo. As we can see that the display will uh, display the initial buffer contents on the screen, which is the Adafruit Industries logo. So after that it will clear the display and draw a pixel at 10,10, and then display will uh, display whatever is there in the buffer, which is this pixel 10,10. So after that it delays for 2 seconds, and let's try to write our own text. So here in the example code, if you come down, you will if you scroll down, you can see a test draw styles. So inside this they have written the uh, code for the characters. As we can see here, test draw styles. So here they have defined the text size, and then at 0,0 they are displaying hello world. Okay, so let's make use of this one. Just copy it and we'll paste it here. So it clear the display, set text size to 1. Let's try to set the size to 2, then set cursor 0, and then display this. So let's say I want to display my name. I'll write my name, and after this we need to write the display to display whatever is there in the buffer, which is Aditya. Okay, so that's it. We'll try to compile and see if there is any error in the code. As you can see, there is no error. Let's try to upload this and check. So once it's uploaded, we should expect the Adafruit Industries logo first, and then a pixel at 10,10, and then we'll expect our my name. So if you are using a OLED display which supports both SPI and I2C, you can easily convert them by modifying some resistors. So first of all, to know whether your OLED display supports this SPI to I2C conversion, you can see the back side of the board. So there will be some print which says that you can convert them from one protocol to another protocol. So as you can see here, it says that for I2C configuration, you need to modify these resistors. For 4-wired SPI communication, you need to modify these two. For 3-wired hardware SPI, you need to modify these two. So there are many different versions of this board available, and these two are the common ones. So if your board looks like the left hand side, all you need to do is you need to replace the resistor R3 with R1. So you need to remove the R3 and then place it onto R1. Then you need to short the R8, and R6 and R7 are already soldered, so you don't need to do anything. So by default it will be in SPI configuration, and if you want to do an I2C conversion, you need to modify that. Then if your board looks like the one which is on the right hand side, you need to replace R3 with R1, then you need to short R6 and R5. So usually D0 and D1 will be SCL and SDA as mentioned here. So I am using the board which looks like a right hand side, and we'll see that conversion.
So in my version, we need to connect this resistor from R3 to R1, because in I2C we have R1, R4, R5 and R6, and then we need to just short R6 and R5. So anyway, this resistor is 0 ohms. I think it doesn't matter if we put the resistor or just short it. Anyway, I'll put this resistor from R3 to R1. Okay, so we'll solder it and then come back.
So once the soldering is done, so we'll make note of the SCL and SDA pin. We can see here. So SCL is D0 and SCL is D1. So plug this onto the breadboard. So the ground will go to the ground of Nano, and the VCC will go to VCC 5 volt. Then we have D0 and D1, which is SCL and SDA. We need to connect it to the pins of Arduino Nano. So to know which pin to connect, you can go to File, Examples, Add a fruit, and we are using now I2C. Select I2C, and we can see here in the example code that on an Arduino Uno, default A4 is SDA and A5 is SCL. So always in Arduino Uno or Nano, A4 is SDA and A5 is SCL. Okay, so now we need to connect SCL to, that is D0 to A5. So this is SCL D0, we will connect it to A5. Then this is SDA connected to A4. So after that we need to connect the DC to either ground or VCC. So here you can see that screen address is 3D. So if it's 3D, connect it to VCC, and if it's 3C, you can connect it to ground. So I'm using 3D now, so therefore connect the DC pin to VCC. So you can play around with it until the display works, whatever works for you. Okay, so now we'll power up the board after the connections, and then we'll try to compile this, and we'll try to upload the sketch. So as we can see, once the sketch is uploaded, you can see Adafruit logo and the display is working. Okay, so that's it for the tutorial. Hope you liked it, and we'll see more projects in the next video. Thank you.